Hello everyone, welcome back to my channel Learning Science, and in this video we are going to continue part 4 of chapter 4, materials, metals and non-metals. The topics we will be covering in this video are reaction with water, acids and bases. So let's start. Reaction with water. How metals react with water. So we see that metals like sodium and potassium, they react vigorously with water and oxygen. A lot of heat is generated in the reaction. Therefore, they are stored in kerosene. Now what they're saying here is that like metals like sodium and potassium, they're very they react very vigorously with oxygen and water, and also a lot of heat is generated in the reaction. To prevent this this contact of the metal like sodium and potassium with oxygen and air, it is stored in kerosene, because otherwise if they will react, then they will catch fire. Okay, so to prevent this fire and prevent this reaction that may happen with the oxygen which is present in the air as well as water, they are stored in kerosene. However, some other materials may not do so. For example, iron reacts slowly with water. So there may be some exceptions like iron. It is a metal which reacts slowly with water. Okay, it may happen with some metals like they may be very reactive with oxygen and water, or they may be not so much reactive like iron is there. And this is an activity here which shows how that sodium react with water. To be demonstrated by the teacher. During demonstration, special care should be taken that the size of the sodium metal piece is roughly the size of a wheat grain. So it is clearly mentioned here that the sodium metal piece which we will be taking in this activity should be roughly the size of a wheat grain. And why is it so? Because sodium is a metal which reacts vigorously with water, as I have already learned here. So if we will take a large amount of sodium, then it may react so much with water that it may catch a large fire, okay, which will be very difficult to control. So to prevent so much, it's only an activity where we need to see that how heat is produced. So we don't have to see a lot of heat. We don't have to generate a lot of heat. Only a small one will help us understand this activity. Okay, so a small piece of wheat, small piece of sodium we will take. Now take 250, take a 250 ml beaker or glass tumbler, anything you can take, and fill half of it with water. Now carefully cut a small piece of sodium metal and dry it using a filter paper and wrap it in a small piece of cotton. Now put the sodium piece wrapped in the cotton into the beaker, and the beaker is filled with water. Now observe carefully. Now there's another caution, that is during observation, keep away from the beaker. And why is it so? Is because the heat which will be generating, that may be harmful. So just to see what will be the reaction, that you need to be you need to observe it from a little distance away from the beaker. Okay, because maybe a sudden reaction may take which may harm the students. That's why. When reaction stops, touch the beaker. What do you feel? Has the beaker become hot? There's a solution with red and litmus papers. Is the solution acidic or basic? Now here, when we touch the beaker, it is very hot. Okay, why? Because heat is generated. Okay, so this shows the reaction of sodium with water. Now let's see reaction of non-metals with water. We see here that generally non-metals do not react with water, though they may be very reactive with air. So here we found that non-metals, they are not very reactive with water, although maybe they may be very reactive in air. Such non-metals are stored in water. Obviously, to cut the supply of prevent basically the contact of any non-metal coming with the contact of air, and air contains oxygen. So to prevent that contact of the non-metal and the oxygen, it is stored in water. For example, phosphorus, it is a very reactive non-metal which catches fire if exposed to air. So it is also very reactive with air, that it will catch fire if we leave it to air for a long time. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. As I've seen above, to prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Okay. Now reaction with acids. Generally, we see that non-metals do not react with acids. If we talk about metals, metals react with acids and also produces a pop sound when a burning matchstick is brought near the mouth of the beaker or the test tube. So this is a test tube, as you can see, and it contains a metal, any metal, and an acid, like for example hydrochloric acid. Any acid you can take, and when you bring a burning matchstick towards the beaker, a pop sound is produced. And this pop sound is the indication of the production of hydrogen gas. So we say that hydrogen gas burns the pop sound. So this pop sound that we hear, it means that hydrogen gas is being produced from the beaker. Now let's see reaction with bases. Again, we see that reaction of non-metals with bases are complex. So there's nothing, any fundamental thing about the non-metals reaction with bases. If you again see with metals, then we see that metals react with sodium hydroxide. Sodium hydroxide is a base. So when metals react with sodium hydroxide, they again produce a pop sound, which is the indication of the production of hydrogen gas. So when a burning matchstick is brought near the mouth of the test tube, hydrogen gas is produced with a pop sound. Okay, clear? Okay. So here we come into our session. Thank you so much. For more such videos, subscribe to our channel. Thank you. Our part 5 is coming soon on the displacement reactions, a very important topic. So stay tuned for watching that. Thank you. Keep learning.